Welcome to the NetHub. In today's video, we're going to talk about calculus, and our focus is going to be on the absolute definition of a limit. So we have a problem that's broken into two parts. There's part A and B. So the problem asks us, it says, how close to 2 do we have to take x so that 2x plus 5 is within a distance of A 0.1 and B 0.001 of 9. Now, if you look over to the left, it says to have 2x plus 5 within a distance of 0.1 of 9, we must address f of x. Now, f of x is used interchangeably with y. If you look to the right, you will see y is equal to 2x plus 5, so y is equal to f of x. We can use that interchangeably. So, going back to the left, it says keeping f of x within a distance of 0.1 of 9 basically means that we don't want a deviation more than 0.1 in either direction of 9. So if we go to the right, that's 9 plus 0.1, which gives us 9.1. And if you deviate to the left of 0.1, that would be 9 minus 0.1, which would put us at 8.9. So as a result, we need to keep f of x in this tight range between 9.1 and 8.9. And as this inequality basically reads, it says 8.9 has to be less than or equal to f of x, which is less than or equal to 9.1. Now, since f of x is equal to 2x plus 5, we can substitute f of x for 2x plus 5 in our previous inequality. And now we have 8.9 is less than or equal to 2x plus 5, which is less than or equal to 9.1. All you have to do now is subtract 5 on each side, and you'll have 8.9 minus 5 is less than or equal to 2x, which is less than or equal to 9.5 minus 1. Subtracting 8.9 minus 5 gives you 3.9, and subtracting 9.1 minus 5 gives you 4.1. Again, you have 2x, so you can divide each side by 2 so that you can solve for x. You divide each side by 2, you eventually get 1.95 is less than or equal to x, which is less than or equal to 2.05. So essentially what that tells us is that if we keep x between 1.95 and 2.05, we can keep 2x plus 5 within a distance 0.1 of 9. As a proof, we can just take 9 and we can subtract 2x plus 5. And we can plug x in, and in this case x would be 1.95. And if we subtract that, plug x in and subtract from 9, we get 0.1. Likewise, we can take 9 minus 2 times 2.05, which is the other x, and add that to 5, and we subtract that from 9, and we get negative 0.1. So essentially, by plugging x back into the f of x equation, we see that we can keep the deviation from 9 at a distance of 0.1 or less when we plug in x whenever we're working our proof. Now for part B, it's essentially the same thing. So part B, basically the problem says how close to 2 do we have to take x so that 2x plus 5 is within a distance of, in this case B, 0.001 of 9. So for part B, we're essentially doing the same thing. If we look over to the left, it says to have 2x plus 5 within a distance of 0.001 of 9, we must address f of x. Keeping f of x within a distance of 0.001 of 9 means, again, f of x, if we have 9 deviating to the right at plus 0.001, that gives us 9.001. There's a deviation to the left, 9 minus 0.001, that'll give us 8.999. Which means we must keep f of x between 8.999 and 9.001. In other words, we have an inequality. 8.999 must be less than or equal to f of x, which is less than or equal to 9.001. Again, since f of x is equal to 2x plus 5, we can substitute it into the equality and do the same thing as we did in part A. We subtract 5 from each side. That gives us 3.999 is less than or equal to 2x, less than or equal to 4.001. We divide each side by 2, and now we have x 1.995 is less than or equal to x, which is less than or equal to 2.005. So if we keep x within this range, we can keep f of x within 0.001 of 9. In other words, we can keep f of x, which within a distance of 0.001 of 9. And that's what our solution says. As a proof, again, we can do like we did in part A. We can plug f of x into our equation, and we can subtract it from 9. In this case, f of x would be 2x plus 5. We substitute x for 1.9995, and we subtract that from 9. It gives us our distance is 0.001. Likewise, if we subtract 9 from 2x plus 5, with x being 2.005, we get a distance of negative 0.001. So in other words, once we plug our x back into f of x, which is 2x plus 5, and if we subtract that from 9, that gives us our deviation with a distance no further than 0.001 of 9 in either direction. And that's how we know that if we take x between 1.995 and 2.005, we can keep f of x, which is 2x plus 5, within a distance of 0.001 of 9. Now this says within a distance, as you can see that it's better said it can be at that distance or less. So that's another way of thinking. Basically, it can be at a distance of 0.001 or less, as long as you keep x in that range of 1.995 and 2.0005. That's it for this video. If you like this video, please subscribe and like, and even share if you really like it.